right, today we are going to be talking about piecewise functions. So a piecewise function is a function where we have more than one equation and they're each given a portion of the domain. So first we are going to be evaluating piecewise functions algebraically. So what that's going to look like is your piecewise function will be written in function notation, and you will see your 2, sometimes 3 or 4 different equations, and next to it, it will tell you over what x values, what domain you will use that equation, and over what domain you will use the other equation or equations. So if we're going to evaluate the function, so like this first one, we want f of -4. Well, I have to figure out where in the domain that falls to know which equation to use. So remember, this one is broken up into x is less than 0 and x is greater than or equal to 0. So for numbers less than 0, I'm going to use x squared plus 1. And for numbers greater than or equal to 0, I'm going to use x minus 2. Well, -4 is less than 0, so I'm going to use the upper equation, x squared plus 1. And I'm going to plug in -4 in place of x, follow my PEMDAS, and f of -4 is going to be 17. So somewhere on my graph, I would have a point -4, 17. Okay, f of 0 is the next one, so I need to figure out where x is 0. Now this top one is x is less than 0, the bottom one is x is greater than or equal. So I'm going to use the bottom equation for this one. So 0 minus 2, which is going to be -2. So we would have the point 0, -2 on our graph. Okay. Lastly, f of 10 plus f of -2, that means I first need to find each of those values. F of 10, that is going to be from my bottom equation because it's greater than or equal to 0. So that's going to be 10 minus 2, which is 8. Then for f of -2, I use the top equation because -2 is less than 0. And that is going to give me 5. So for f of 10 plus f of -2, that's going to be 8 plus 5, which is 13. Okay. We are going to practice evaluating again. On this function, I have 3 different equations. So -2x plus 8 will be used when x is greater than or equal to 1 but less than 6. When x is equal to 6, it's 5. And when x is greater than 6, 1/3 x minus 8. So first, g of 9, where does this fall? Well, that is greater than 6, so I am going to use 1/3 x minus 8. Order of operations says I multiply first. 1/3 times 9 is 3. Once I subtract 8, I get -5. So I have the point 9, -5 on my graph. For g of 6, when x is equal to 6, y is 5. So that one I don't have to do any math, I just need to look it up. So the point 65 is going to be on my graph. G of -2. Now, my domain only goes to 1. It does not go smaller than 1. So that is going to be undefined. I do not have an x coordinate of -2 on my graph. Okay, so that is evaluating algebraically. Now we are going to go on to graphing piecewise functions. My suggestion to you for graphing your piecewise functions is to have one table per equation that is part of your function, and then you can graph those points. So for this graph, when x is less than -1, I've got -x minus 2, and when x is greater than 2, it's going to be 2. So for this first xy table, I am going to start with my boundary of -1 for x, and now notice this inequality is not underlined. So that is going to be an open circle on my graph, and I want to put a little note there to remind myself of that. But if I were to plug that in here, negative of -1 becomes +1. 1 minus 2 is -1. So that's going to be an open circle on my graph. From there, I can put in any numbers less than -1, like -2, -3, and so on. If I plug in -2 here, I get 0 as an output. If I plug in -3, I get 1. -4 is 2. -5's output is 3. -6 output is 4. Negative 7's output is 5, and that would continue on. So I'm going to go ahead and graph that, starting with my open circle at the point -1, -1, and then I'm going to graph my other points. This graph got really light, but that is going to be going on forever. And so I'm going to indicate that with the arrow. There is the first part of my graph. For the second part, when x is greater than 2, y is going to be 2. So the start of that domain boundary is 2, but again, this inequality is not underlined, so that is going to be an open circle, and I'm going to write that there to remind myself of that. So 2, 2, and then again, I'm going to go up any values greater than 2 into my table, and they are all going to have a y coordinate of 2. So to graph this portion, I'm going to start at 2, 2, and this is just going to look like a horizontal line. And again, it's going on forever, so I'm going to indicate that with an arrow. Let's practice graphing again. On this one, I have 3 graphs, so I've got, 3 equations that are part of my function, so I'm going to have 3 tables. This first one, I've got x plus 6. That is from -5 to 0. So I want to make sure I've got all of those parts for x from -5 up to 0. And now neither of those are underlined in my inequality, so I'm going to have 2 open circles. Now I'm going to fill in the y portion of this table. It's just going to be x plus 6, -5 plus 6 is 1, -4 plus 6 is 2, -3 plus 6 is 3, -2 plus 6 is 4, -1 plus 6 is 5, and 0 plus 6 is 6. For my middle one, it's only when x is equal to 0, and my y coordinate is -2, so that one's really easy. And then for this third one, between 0 and 6 for my x coordinates, so I'm going to make sure I get all of those, 0, 1, 2, 3, 4, 5, and 6. The 0 does not have an underline, so that's going to be an open circle, but the 6 does, so it gets a closed circle. Now I need to fill in the y's here, and they are all going to be -3. Now what's different about this one from the first example we did is that each of these domain portions have a specific start and stop. They're not going to be going off to infinity like on the previous graph. So we're going to have to make sure we start and stop, we don't have arrows. So starting on this first one, -5, 1 gets an open circle. Then I have -4, 2, -3, 3, -2, 4, -1, 5, and 0, 6 with an open circle. And those dots aren't perfect. Again, my graph printed really light. Okay. Then at 0, -2, I have a point, just 1 point. Then here, again, I have an open circle at 0, -3. And then 1, -3, 2, 3, 4, 5, and 6, and that is where it stops. So quickly, I want to show you what this is going to look like on your Delta Math homework. Okay, so this is what a problem would look like for you on Delta Math. You've got your 3 intervals here. So starting with this first one, x minus 1 for this interval. So I'm going to have a closed circle here, open circle here. What you're going to do is graph your various points. So I know I'm going to have a point at 2, 1, and then I'm going to have another point at 3, 2. So I'm going to drag, and then I have 4, 3, 5, 4, and 6, 5. Now, I have a closed circle at 2 and an open circle at 6. So I'm going to click on that circle to change it to open. My next interval, at x equals 6, I have -3, so 6, -3 is just a point. So I just want that point. So I have to click close circle to graph that. Oops, sorry, closed circle, not open circle. There it is. Then I'm going to do line again, and this is where x is greater than 6, and that is going to go on forever. So I'm going to drag starting at the at 6 going on to -4. This needs to become an open circle, so I have to click on it to change it to an open circle. And this needs to become an arrow, so I'm going to have to click on it twice to make it an arrow to indicate that it is going on forever. Okay, so that is just a quick rundown on how Delta Math wants you to do that. Okay, the last thing we are going to do is write piecewise functions when we're given a graph. So this means you have to do two things. You have to write the equation and you have to write the domain which it is under. So starting with this first graph, I've got two portions. This first portion on the left, it's just a horizontal line where y is -4. So that's my equation, -4. Now I have to figure out under what domain this is happening. I've got an open circle at -3 and it's going off to -infinity. So that means that x is less than -3. Again, this indicates an open circle, which matches with what is on my graph. Okay, my line picks up again here, starting at x equals 3. And what you can do here to figure out what your equation is take 2 points and find your slope. I've got this point here at 3, -1. And I know this printed super light, but the next time it crosses at an exact point is at 6, -6. So if I use my slope formula, that's going to be -6 minus -1 over 6 minus 3. And so my slope is -5 over 3. So -5 over 3x. Now I just need to figure out what my y-intercept is. Now if I go backwards and I go up 5 and over 3, it's going to cross the y-axis at 4. So -5 over 3x plus 4. And that is for all values where x is greater than 3. Again, open circle, so it's not underlined. Okay. On this last one, I have 3 portions of my interval, so we're going to have 3 equations. Starting here with this open circle, I need to figure out the equation where x is less than 2. So if you want to go ahead and just write down your domains, that might be helpful. So again, I need to find 2 points and take the slope between them. This graph printed really light, but I have another point at 4, -2. So that slope is going to be up 1, 2, 3, and over 2. So I have 3 over 2x for my slope, and if I repeat that going up 1, 2, 3, and over 2, I'm going to have a y-intercept at 4. So 3 over 2x plus 4 for my first equation. For my next equation, I'm going from closed circle at -2 to open circle at 1. So there is my domain. And I can already see that it crosses the y-axis at 7, so I know that's going to be my y-intercept. Now I just need to find the slope. And this is actually just going up 1 and over 1 every time. So it's just going to be x plus 7. And then lastly, we've got our values where x is greater than or equal to 1. And I need to figure out this slope. I've got another point on my graph at 2, 2. So that is going down 5 and over 1, which means I have a slope of -5. And I need to just find my y-intercept. So if I was going backwards from here and I went up 5 over 1, that would put me at 12. So there are my 3 equations for this graph and my 2 equations for this graph. And that wraps up our first day of introducing piecewise functions.